Hey guys, how are you? Welcome to the first CUAUV webinar. This one will be on team organization and running a team, so mostly just administrative, a guide to administrative things for running a RoboSub team. I'm Alex Malcochi. I'm team leader for CUAUV, and let's just get right into it. All right, so who are we? Cornell University Autonomous Underwater Vehicle Team was founded in 1999 as BRAIN, the Big Red Autonomous Intelligent Navigator. We rebranded as CUAUV because BRAIN just sounded kind of lame. So, in the past 15 years, we built 14 vehicles. Number 15 is in progress. We've competed 15 times. We've won 6 times, first time in 2003, and we've won 5 of the last 6 years. That makes us probably the most successful team at RoboSub in terms of wins and static judging. We've placed top 10 every year that we have competed, so we've done decently. We hope that we can share some of our knowledge with you guys. So who are we as a team? We are a team of 38 undergraduates at this point, from 10 different majors, from 3 different Cornell colleges. So that's very interdisciplinary. We're not all engineers. We have a lot of different majors involved. We advertise this as a hands-on experience. It's one of 20 plus engineering project teams at Cornell. The program is growing very fast. Maybe like 4 or 5 teams are being added every year. We're very multidisciplinary, as I mentioned, 10 different majors, all working together. It's a very complex project that requires a lot of different skill sets. We pride ourselves on project ownership. So that means that every member on the team has a project and they're very proud of it and it's their project. We provide full training, so we don't expect anyone to come in with experience. We basically spend the first year just training them on how to use our system. For our sub, which we build every year from scratch, we spend about 20,000 plus man hours at least. So who am I? I'm Alex Malcochi. I'm that guy in the picture. I'm a mechanical engineer, class of 2016, and the current co-team lead of CUAV. I have 7 years of competitive robotics experience and lots of experience doing that. So yeah, I also mentor FRC Team 334 if any of you do that. All right, so a bit of information regarding the webinar program that we're putting on for you guys. So the goals of this are just to create a discussion about RoboSub during the so-called off-season. There really isn't an off-season. I know we're all working hard on this. So we're just generally trying to share knowledge accumulated over our 15-year history. So there's a lot of knowledge that CUAV possesses that other teams may not, just because we've been around for so long, and we kind of want to get rid of that barrier and create a very fair competition for everyone. So this is also for us, so we do want comments on our system. So we will be presenting many aspects of our system. So feel free to comment, let us know if we're doing something wrong. We very well might be. And the ultimate goal of this is to elevate the level of competition at RoboSub. We want to see every team doing very well. We want to see every team being capable of, competing at the highest level, making it to finals, and so on. So the schedule for these webinars can be found at our website, cuauv.org. We will post the links to the YouTube streams there, and videos will be posted on our YouTube channel immediately after webinar. That's how Google Hangouts on Air works. You can basically just watch it anytime from now on. The presentation will be followed by a Q&A session, so feel free to send questions to that email, which you can also find at the bottom of every slide, so don't worry about it too much. This will change every time. Also, if you have any questions regarding any of the webinars, feel free to ask them during this webinar. All right, so let's get into this. So first point of discussion would be division of labor. So for a successful RoboSub team, you can realistically have between 10 and 50 people on your team. Some teams can do it very well with 10 people. Some can do it very well with 50 people. It just depends on what your goals are. You may or may not be building an AUV from scratch every year. Just keep this in mind. So generally, more people equals more focus on individual projects. So individual projects will be done better because you have more people focusing on them. Too many people, however, means there's not enough work to go around and people just lose interest. Too few people and they're overworked, overstressed, and you don't want to see that. It's going to be a disaster. So you want kind of just the right amount of people working on a project. And that's not too difficult to determine, actually. So the solution to this is very simple. You just list all the major projects that you can realistically give to a person during one design cycle. So this is very dependent on your resources. So just imagine what one person can do in a year, realistically. I'll give you some examples of projects like this later on, but just imagine what that is for your vehicle. Now, this number should be the number of members that you need on the team. You shouldn't have too many members. You shouldn't have too few members. If you do have too many members, you should be recruiting more selectively. If you have too few members, you should be recruiting hard. Recruiting is a big deal. All right, so the goal of a project, it's to provide enough work for a person to do during one design cycle. I cannot stress that enough. You need to keep a person devoted, dedicated. You want to give them work that is fulfilling to them. It needs to be difficult enough to maintain motivation, but not too difficult that they'll give up on it. It needs to provide a method of learning so you can step up to more difficult projects. So an entry-level project is going to be very basic compared to what you will be doing maybe your 4th year on the team. A project, at least in the CUAV philosophy, should always be mission critical. So the project will always be something that's used on the sub to score points in some way, whatever that may be. Without their project, we cannot compete. And that basically builds a lot of motivation. You really feel, a connection to the team and that your project is worth doing. So there are 4 levels of projects as we see, at least on our team. Entry-level projects are projects that we give to members that just joined the team. So they're a basic intro to our methods and systems. This can be very simple. Just most upperclassmen, most veterans on the team can basically do these projects in a couple weeks, a month. But a new member will take a year to do them in many cases, just because of the complexity of our system that already exists. Second year project will be a very core component used in our system, something that will take them a year to do with experience, something basically the bread and butter of our system. A veteran project would be something very complex that involves communication and coordination with other people, coordinating other people, being in charge of other people, talking to different disciplines, and so on and so forth. And then we have a category called research and development, which are very complex and new projects that may or may not work. These are not mission critical. I did mention that projects should be mission critical, but these are some of the ones that we don't hold to that standard just because of interests that they create. So a person works on research and development once they've done maybe a veteran level project or 2, and they feel that they can do more by researching, they can stay more interested. So this is for people who've gone, above and beyond and really want to create something new. So I'll give you some examples of projects, at least on CUAV. So for entry level, we have on the electrical side, maybe an LED control board, an actuator control board, simple boards, nothing too crazy. On the mechanical side, we have camera enclosures, maybe a torpedo launch system, maybe our marker droppers. So all mission critical, but very, very simple. It teaches them maybe how to use, our CAD, our layout tools, and so on. On our business PR side, we have maybe poster design, basic stuff like that, just to get them acquainted with our team. And then for software, at this point, we are doing full software training. So new members come onto the team and they just get trained. For a second year member, some electrical examples would be a power distribution board, a serial communications board. So once again, the bread and butter of our system. For mechanical, it would be something, usually a CNC part, just because of the way our machine shop works. So it'd be a valve enclosure, an electronics rack, something of that nature. For software, you start getting into the fun projects. Basically, your freshman year, you get acquainted with the system and you see its flaws and you want to improve on them. So often you're devising little utilities or integrating a new sensor, trying to make something work better, and it's up to you. For business, you'll be doing a lot of fundraising, alumni relations, kind of stepping it up from poster design. As a veteran, you'll be doing a lot of the very complex boards that need to work right the first time. So thruster boards, we don't want our thrusters failing ever. So that's a veteran board. It's also one of the more complex boards. We have a PCB backplane that's in the works. That's very much a veteran project because it involves coordination of all our electrical boards. On the mechanical side, our upper hull, our frame are both veteran projects just because they involve coordination with the whole mechanical team, the whole electrical team, and so on. And they're very, very machining intensive, very much CNC. So they're difficult projects meant for a veteran member. On software, maybe we have our controller. So the thing that takes what our code wants the sub to do to what our thrusters actually do. That's a very complex system. We're always developing it. We're always working on it. Our mission system is also something that we keep working on. It's the framework for what other people will work with. So we want it to work right. We want it to work well, so it's a veteran project. On the business side, branding guidelines, fundraising campaigns, so very high-level things that determine what everyone else does. Now, for research and development, these are projects that basically people come up with and they say, wouldn't it be cool if our submarine, had a carbon fiber frame? Okay, go ahead and do R&D on it. And maybe in, 2 years down the line, we'll start using it. So this would be stuff like custom thrusters, a carbon fiber frame, as I've said, things of that nature. On the electrical side, maybe hydrophones, maybe a brushless controller for those custom thrusters, and so on. It usually involves 1 or 2 people working together. It's basically dedicating their time to it. And this may or may not be a multi-year project, so someone may take it over at some point. So this is kind of how we structure our team to make this work. So we have a very strict hierarchy. You have your team leader on top, you have your mechanical, electrical, software, business leads below, and then you have sub-teams below that, and then you have members below that. So really, you'll only ever have contact with maybe 3 or 4 people directly above and below you at all times. And let's see. So that's your immediate work group, and that's all you really have to worry about. Those are the people you'll be meeting with most often. It basically doesn't overwhelm people, especially up in leadership when you have maybe, a dozen or 2 dozen people below you to take care of. You don't have to worry as much. Okay, so here are the roles of these positions as we see fit. A sub-team member is someone who works on an entry-level or first-year project. Generally, it's a new or first-year member. We hope that they will one day become leaders. It's just newer people on the team are generally sub-team members. A sub-team leader works on either a first-year or a veteran project. They advise sub-team members and they manage the sub-team budget. So this is our lowest level of leadership, but it's a stepping stone to higher leadership. So we try to introduce people to leadership early on and promote them as much as possible. Then we have what we call our super leads, our electrical, mechanical, software, and PR leaders. These are the people in charge of those sub-teams. They are in charge of all the sub-team leaders. They work on veteran or research projects, so the most difficult projects that require the most coordination. They advise sub-team leaders and members. They advise everyone below them. They manage the budget for all sub-teams below them, so they basically manage the budget for either the electrical, mechanical, whatever sub-team. They do most of the coordination work between sub-teams. So if mechanical has a problem with electrical, the mechanical lead and the electrical lead get together and talk it out. So the team leader generally does not have a project, just because team leader is generally a project within itself. Basically, the team leader advises the electrical, mechanical, software, and PR leaders, basically just keeping them organized and on the same track, organizing meetings between them, just making sure the whole system is there. If anyone has a question, they can come to you and you can direct them to the right person. That's the team leader's role. The team leader manages team budget and purchasing. At least for us, that's just administrative. The team leader also manages administrative relations. So everything from talking to the university to dealing with alums to organizing conferences and so on and so forth. And very high level coordination of sub teams. So as I said before, they are the ones to ask in regards to a question where you don't know where to get the answer to. They can direct you. They have a very high level idea of where the sub is going, and they can basically help you out. So here is what a branch of this hierarchy would look like, just in more detail. So you have your team at the top, then you have your mechanical leader in this example, and then below them you have 3 sub teams. You have your structures, actuators, and rack sub team. You can pretty much figure out what those individual sub teams do. So that's what they're focused on. Generally, there are about 3 members in each sub team: the leader and 2 members below them. The job of the leader is to basically tutor them and just make sure they become productive members on team, keep a check on them, make sure they're doing okay. So as I said before, your immediate work group members are the 3 to 4 people directly above and below you. So if you're the structures leader, you'll only ever have to meet realistically with the 2 members below you and the 1 member above you. And that's all you really have to worry about. So promotion. Generally, older members take leadership positions just simply due to experience. The more time you spend on, a sub team, the more submarine knowledge you'll have. If a newer member looks promising, early promotion is definitely encouraged. So maybe a first-year member, you see potential in them, you give them a much more difficult project, you give them, a higher position. Basically, more responsibility equals more room to grow, and you get more return on your investment. So each person that we take on the team is an investment for us. The first year that we spend training them, we expect 3 years out of them in terms of return. So we spend a lot of time training so that we can have a productive member for 3 years. And the more you do train them, the better your return will be. So generally, we let members choose their own projects, of course, with guidance. So before our sub is even finished, members generally know what they're going to work on for the next submarine. It works out pretty well within the team. Everyone kind of discusses it, and they love doing so. So this enjoyment, so dedication and attachment to your project generally leads to more effort and generally leads to more, promotion and hopefully good things. Okay, so the unfortunate side effect of this hierarchy are the meetings on meetings on meetings. So there are many, many meetings that a CUAV member goes to generally. So the benefits of organized meetings like this are that they are a chance for questions to be asked and answered in, an organized situation. So all the members are there, you can just ask and we can have, a discussion on it and hopefully get an answer. Meetings help us keep track of how members and projects are doing. So if a member's falling behind, we can, do our best to help them, send resources that way if we need to, so on and so forth. We can identify conflicts, so both technical and personal. We generally don't have personal conflicts, but technical conflicts, if one sub team is planning on doing something and another sub team is planning on doing the opposite, this is a good chance to identify that. It's also a very, very efficient way to transfer knowledge. By hearing what every other sub team is doing, you generally get a very good idea of how our submarine is doing, how our submarine actually works. And you get that high level knowledge from these. So a typical weekly meeting schedule for a member of CUAUV looks something like this. So there's a team meeting once a week on Sundays where we share big news with the team, and then we go and we pool test. That's a weekly thing during the semester. Then you have mechanical, electrical, software, and business PR meetings. Those are generally the most extensive of the meetings. That's where high-level decisions are made within those sub-teams, and we have design reviews. So, the mechanical team might meet for 6 to 7 hours a week just to do those design reviews where we just sit around and critique each other's work, and that's how that works. Sub-team meetings are medium-level decisions, so that's usually once a week where you just meet with your sub-team. So maybe the structures sub-team within mechanical meets, and they all just discuss their designs and kind of point out mistakes before we go out and actually do a full design review. It's also a good chance for an upperclassman to help the new members. If they're having trouble with something, you can just ask away. Now, in addition to this, for leaders, there are leaders meetings. So all sub-team leaders end up just meet and give status and just discuss just have a high-level discussion on how everything is going. Then there's also super leaders meetings. So electrical, mechanical, software, and BPR leads meet with a team leader, and you just discuss very large things. So very large purchases, very, very large scale decisions on the submarine. So leaders meetings are generally weekly. Super leaders meeting are more of, if we need to have one, we will have one. So our design cycle looks something like this. So we design for about 4 months. Generally, the design cycle starts almost as soon as we're finished competing. After designing for 4 months, we do what's called a design freeze. So we just stop designing, no more changes. That's it. We manufacture for about 3 months. And then looks like I goofed right here. So after we manufacture, we integrate. Sorry about that, guys. I'll fix it when I upload the PowerPoint. Integration is about a 1 month long process followed by testing. We test for approximately 3 months. That's about 300 hours of testing just for us. And then we compete, right? Our competition is 1 week. We rest afterwards. And usually during testing and competition, we note all the changes that we need to make during our next design phase. So then we just jump straight into design and start it all over again. So it's a very fluid process. We're always thinking about what to do better next time. All right. So that is it for me, guys. If you have any questions, feel free to send them my way. These can be questions on anything ranging from what the webinars are about or the presentation. I'll give you guys 2 minutes to do so. All right, feel free to keep on sending in questions. I have one question here. Being engineering students, semesters can be quite stressful and demanding. Can you please describe the culture at CUAUV that facilitates academics and project progression? basically, how do you guys get the sub built and manage school simultaneously? So this is a very good question. On CUAV, it's always academics first and then the sub team. Generally, the AV team is the biggest commitment for most people, and that whole academics first thing, we're being serious about that. If you have an exam coming up, we plan around it. We generally have our exam schedules very well mapped out in advance, and we plan literally every meeting, every design review around that, so you never have to have that conflict. It's all in the planning. We all basically take the same classes together, so generally all the CUAV members are sitting together in class. They'll be working on homework together, projects together, and so on and so forth. We're more than a team. We're friends. So this culture that we inspired, it's very conducive to being a good student, very conducive to building a good submarine. We try to do both very well. So to answer your question, it's all just planning and scheduling. Just get that straight, and it works out. So another question from the same email. Can you please describe a time that there was conflict on the CUAV team? How is the conflict resolved? So conflicts very often arise within the team just based on things that we want to see on the submarine. I'll give you an example of a discussion that we had this year. So for the past few years, we've opted for 2 forward cameras in order to have stereo vision. However, this year, we're making some changes, and we may or may not have enough money to upgrade all our cameras and so on and so forth. So we were looking at the option of not having, a forward camera. I mean, 2 forward cameras just for stereo vision. Having just one and maybe investing in sonar or something like that. So decisions like this, generally members are very passionate about projects like this. You are taking away a project when you're deciding, no, we will not do, stereo vision. So this is one of those discussions that we have at the super leaders level. So basically we just organized a super leaders meeting. We sat there for 2 hours discussing the pros and cons of the decision. And, you just come to a conclusion. That's what these leaders and super leaders meetings are for. More so, just there shouldn't be one person making all the decisions. It should be, a committee. Maybe the committee isn't the entire team, but at least the high-level members should be the ones making this decision. All right, it seems that we are done with questions. So thank you guys for attending. I hope you enjoyed this webinar, and I hope to see you at all our others.